Hello, welcome to Skylab. My name is Rebecca Cardani-Strange, and I'm an international project manager here at Skylab. Skylab is a technology company based in Hamburg, in Germany. We work with forestry companies all over the world using AI and machine learning to analyze aerial forestry data from drones or planes or satellites to allow you to see 100% of your forest. And our main goal is to give foresters a really comprehensive picture of what's happening in their stands, which leads to savings in time and costs, and ultimately, of course, the increased productivity of those stands. And all of this is done via our Skylab Cloud, which is an online platform that makes everything super quick and is really easy to use. You just upload your aerial imagery. All of the processing and analytics is done in the cloud, and you get results and maps usually within 24 hours. Our analyses apply to all stages of the growth cycle, from planting with a full seedling survival assessment, throughout the growth of the plantation with tree counting for stocking density, health monitoring, and all the way through to harvesting with full timber and carbon inventories. And we do that with these 4 products. So firstly, our seedling and tree counter, which is a 2D analysis of normal color imagery from drones and planes. Our digital forester, which is 3D modeling of your forest with drone or plane imagery. And then the last 2 products, which use satellite imagery to monitor any negative or positive change over time. And actually, that's also one of the best ways of monitoring the performance of carbon projects. Now, at this point, I'd like to pose a slightly provocative question. What would you say if I told you that you could invest €2 and make €1,000 back? Well, I'm going to use this next section to show you how that can be achievable. So as most of you will already know, the traditional way of monitoring the progress of your plantations is by terrestrial sampling. And this is an example of a new pine plantation where the customer has set up 8 plots over the 40 hectares of their stand and calculated a mean density of 1,650 seedlings per hectare, which equates to a 97% survival rate. So of course, they could conclude that that's all great and no action is required. However, those sampling plots represent only about 1% of the total area. And what you don't see, of course, is the remaining 99%, which is effectively a black box. So at Skylab, we count every single one of those seedlings. I should point out this can only be done with very high resolution data from drones. But you not only get a total count, you can also see the density variations across the stand. And then from that, you can look at the causes of those variations, which of course in turn allows you to take targeted action. The resulting density map gives you a very quick and clear overview of where the seedlings are failing and where they're thriving. And in this case, you can see that none of the sampling plots happen to be in the poor performing areas. So instead of the 97% survival that was calculated from the terrestrial plots, the actual figure as an average per hectare is actually only about 82%. So the conclusion is, well, that's actually not so great after all, and action is probably required. We not only show you what is happening in your plantation, but also help you to understand why. And here we have one of our weed density maps that we've overlaid over the seedling density grid map. And it clearly shows, in this case, that the presence of competing vegetation corresponds almost perfectly to the areas of poor seedling survival. We also measure the precise diameter of each seedling. And at this stage, where there's no competition for space, that gives a very good indication of the relative health of the seedlings. And on this map, you can see that there is a significant difference in terms of vitality between the western and the eastern parts of the stand. In summary, then, all of this information gives you a complete picture of what's happening and can obviously help you to avoid any losses and increase your productivity. This stand is a concrete example of the answer to my previous question about investing €2 to make 100, because in this case, if the forester had relied entirely on his initial terrestrial assessment, he would have missed out on nearly €1,200 per hectare of unrealized revenue. So the Skylab Cloud is our interface, as I mentioned before. It's our online platform where all our data is processed and analyzed, and where all the results are then readily accessible to the customer. It's super easy to use so that anyone within your organization can view the results, even people who have no GIS knowledge at all. You can choose which layers of information to view. So here, for example, the orthophoto, the individual points representing the seedlings, as you can see here, and then the density grid map. And of course, you can choose to see the vitality or the weed maps. You can edit the maps yourself, you can share them, and all of this information is downloadable so that you can put it on your tablet or smartphone, take it out into the fields. And it's also compatible with any of the standard GIS softwares. So we've talked a lot about seedlings, but of course we can also count mature trees using either drone imagery again or plain imagery, because obviously the objects are just much bigger now. And in this example here, there are 3 different age classes in an Australian pine plantation, ranging from 3 years up to 25 years. And while we're counting trees, we can also look at the state of health of each individual tree. And that's done just using normal RGB color imagery. So here the red spots show completely dead trees, while the yellow spots indicate stressed or dying trees that have these discolored crown tips. And of course, in many cases, you just can't see that from the ground. And the density map there shows the health variation across the whole stand and highlights all the problem areas. So the count gives you a precise stocking density grid map showing the number of trees per hectare in each grid cell, which of course is extremely useful information in itself for any assessments pre, post thinning or harvesting. And then when you look at that in conjunction with the health status of each tree, you can actually get very prescriptive thinning information. So you can decide to take out first and foremost the weak and dead trees, for example, to avoid the spread of any disease. And then you can see exactly how many trees to take out in each grid cell to reach your target density. So now I'm going to quickly look at 3D modeling, which still uses that drone or plane imagery. The most valuable tool is the tree height model. So the orthophoto on the left shows what looks like a very homogeneous stand on the face of it, but the tree height model reveals a lot of variation. It can be done on the stand level, as you can see in the middle picture. And then if you combine that with the tree count, you can get individual tree heights, as you can see on the right there. And this is a brilliant tool for optimizing any terrestrial sampling, because you can reduce the number of samples and make them more representative. And this is then the fundamental basis for any subsequent volume or carbon modeling. Moving on now to satellite imagery and our change monitor product. So this is, of course, lower resolution, but it's the perfect tool if you want to get an overview of what's happening over much larger areas. This is an example of a spruce forest in Germany, which was badly affected by bark beetle. And actually, it's pretty sad because all of that red color shows the negative change, the damage that's been done on an annual basis between 2017 and 2021. This poor guy lost about 70% of his forest, I think. Just should point out that no terrestrial reference data is needed for this analysis. nor indeed for any of the products that I've focused on here. So you should recognize this picture from a few slides ago. And this is just really to illustrate how reliable our satellite data analysis is at detecting change. So we first identified the individual dead and dying trees with 5 centimeter resolution drone data, which is what I showed you before. And then we did the same analysis with 3-meter resolution satellite data. And as you can see by the 2 resulting maps, that actually the problem hotspots are basically exactly the same. So satellite data can be used very effectively as a kind of first level health monitoring tool. Carbon transparency, it's obviously an ever more important and relevant subject, and aerial imagery can lend real credibility and integrity to forestry carbon projects. You know, you think I'm paying for carbon credits from an acacia plantation in Colombia, for example, but I've actually got no idea whether the thing's even still standing. So the dark red areas basically show clear cutting. The patchy red areas show disease or dieback. The pale green represents forests that's just growing and thriving. And the really dark green is new plantations. So other applications of our change monitor are locating and quantifying the progress of harvesting operations, which can be done on a monthly or a quarterly basis. I mean, in many cases, we know that foresters are driving or walking the boundaries of harvested areas with a GPS to quantify the area. But this tells you exactly what has been harvested, when and where. And a final, although no less important application, is the assessment and quantification of damage following fires or storms. In this case, it was a hurricane in Louisiana. And we can even differentiate between different types of damage. So areas where trees are completely uprooted and areas where they've simply been defoliated. So in summary, then, our precise and comprehensive maps give you more information about your forest in less time and at a lower cost. You can see and understand the changes that are happening and react to them nice and early. You can take targeted action where it's needed, and that allows you to maximize your productivity and efficiency throughout all stages of the growth cycle. Now, we normally offer an annual subscription contract, which includes a 2-month free test phase for new customers, which means that you can trial our products completely without risk, and you can cancel the contract free of charge if you're not happy. You pay per hectare for the analysis results, but obviously the prices are reduced for larger areas. So this is Skylab. Thank you very much for listening.